Hi guys. All right, so it's day 6 with your work, and I want to attempt to transition to some video lessons so that you would be able to utilize your notes while watching this lesson if you're getting stuck, if you potentially just need to hear something explained to you rather than just reading the words. So as you all know, I am not the most tech savvy person in the world, so this is kind of as good as I have right now, just the video with a dry erase board. I have my computer in front of me and then some other materials. I will let you know I won't be able to do like any fancy editing because of the time frame that I have to give it to you. And also, some of you might remember that I have a puppy and you might hear him sometimes. I might also have to pause the video in case he needs something. So we'll just kind of go with the flow and work with what we have. So some of you that I spoke to mentioned that you've already done this assignment, and that's fine. We will, you don't have to watch this if you don't need it. And for those of you that need it, that's great. So the lesson that I'm going to go over today is multiplying binomials by trinomials. So if you recall, before school was closed, we were doing multiplying binomials by binomials. So for instance, I would have given you something like this. All right, so let me get this just a little bit closer. If I'm cut out, no big deal. All right, so we learned 2 ways to do this. One was our foiling method, which was taking the first terms, taking the outer terms, the inner terms, and then the last 2 terms to multiply. Then we talked about the distribution property or the distributive property, and that is the one that we would take our first term of our first binomial, distribute it to each piece. We would take the second term of the first binomial and distribute it to each piece. All right, so that's the method that we're going to use for this lesson, because the foiling method is a little rough when you have a trinomial because you have more than the first, the outer, the inner, the last terms. Sorry, you're probably hearing all of the cars from my neighborhood right now. So, let me review with you this problem that we did right before break, where we just had a binomial multiplied by a binomial, and we used the distributive property to multiply. I'm just grabbing a couple markers because you all know that I really like to use colors. So I'm gonna distribute this x first. So I have x times x, which produces x squared. Then I'm going to distribute x to 8. So I have x times 8, which produces positive 8x. All right, so far so good. Now we need to do the same thing, but we're going to take this 4 and multiply it by each of the pieces in the second binomial. So I'd have plus 4x, and then I have 4 times 8, which is plus 32. All right, the next step would be that we need to combine our like terms. So you can see here that there are no other x squareds. We do have 2 x's that are like terms, which can combine, and then there aren't any other constants. So we will be combining 8x and 4x. So my x squared, my 32, those stay the same. And then I have 8 plus 4, which would produce 12, but more specifically 12x. The very last thing that we want to do is make sure you always have this in the standard form, which means that your exponents or your degrees are descending. So this is already in standard form, so we don't have to switch anything around. And now you guys can hear my cat. All right, so this would be this polynomial is the product of these binomials. All right, hopefully so far so good. All right, so the next thing that we had was the actual lesson where I had a binomial multiplied by a trinomial. In your notes, this is the example you were given. All right, give me 1 minute. All right, let's try this again. So in this problem, we can see that I have 2 terms, and then I have 3 terms in this next polynomial, which means I have a binomial multiplied by a trinomial. So in your notes, I gave you 4 steps, and it's the same 4 steps that you just did. You just didn't know it was broken up into steps. We're going to take the very first term and distribute it to all terms in the second binomial. Then we're going to do the same thing in step 2, but we're going to use the second term and distribute it to each term in the second polynomial, which is your trinomial. All right, so let's go ahead and take care of that. Again, using my different colors so we can see how this works out. I have 3x, and the first thing it's going to multiply by is 6x squared. So I have 3 by 6, which is 18. And then we have to remember that our product of powers property tells us that we're going to add those 2 exponents. So I end up getting x cubed. All right, now I'm going to keep doing this. So I have 3x multiplied by a negative 2x, so I would get a negative 6x squared, because again, I have that exponent of 1 and I have that exponent of 1, and they have to add together. All right, then we're going to do 3x multiplied by 8, which produces 24x. All right, so we're halfway there. Now, step 2 says we're going to do the same thing, but with that second term. So I know this is going to look all crazy, but that's why I'm using those different colors. So I have 11 multiplied by 6x squared, so I actually get 66x squared. Then I have 11 multiplied by the negative 2x, which produces the negative 22x. And lastly, I have 11 multiplied by 8, which produces 88, which I ran out of room, so we'll work with what we have. All right, step 3, we're going to combine our like terms. So we're going to look to see which terms, which letters and exponents we have that are alike, which can combine. So I have x cubed here. There are no other x cubes. So I'm just going to drop this term down because it stays the same. And then I'm going to cross it out so I know that I've already used it and I don't get myself confused. All right, now my next term is x squared, so we're going to look to see what other x squareds we have. So I have negative 6, and then I have positive 66. So when I combine these, I would have 60x squared. Cross these guys out so I don't reuse them. All right, now I have x and x, so look at those terms. I have positive 24, and then I have negative 22, or 24 minus 22, which is positive 2. Cross those out, and then last, this is the only constant I have, so I have plus 88. All right. And this would be my answer because it's already in standard form as these degrees are descending. All right, so what you all will be doing on your assignment, whether you pick the kaleidoscope assignment or the matching assignment, you will be distributing binomials to trinomials as well. I'm just looking over your assignments, seeing what problems I could potentially help you out with. All right, so the matching one is the one where I could see that you might have some questions for me. The kaleidoscope paper is much like the problem I just went over. So what I can see on the matching paper that could potentially give you some questions or some difficulties is you have multiple terms. All right, so let's look, for instance, on the matching paper at question number 4. So at question number 4, you have 4x minus 5y multiplied by 6x squared plus 3xy plus 4y squared. All right, so we can see that we have a binomial multiplied by a trinomial, so we're going to still follow the same rules. I am then going to distribute 4x by each one of these terms. All right, so one at a time, I have 4 times 6, which is 24. And then I have x to the power of 1 times x to the power of 2, which produces x to the power of 3. All right, now we're going to take that over to our next term. So I have 4x times 3xy. So I have 4 times 3, which produces 12. And then right here is where I can see some people possibly getting a little messed up. It's okay that you have different letters. So that rule of combining your exponents only applies if it's the same letter. So you have your x times your x, which is x squared, and then the y just stays put. All right, last one. We're going to multiply 4x by 4y squared. So I would get 16xy squared. All right, so the first term's finished. Now let's take care of that second term. And there's my dog. Hold on. Ollie. All right, sorry. So let's multiply our 5y. I am going to erase this to kind of see if it makes a little bit better sense when you don't have to see all of the extra arrows. When I distribute this 5y, I have to remember that it says minus 5. And let me get this just a tad closer for those of you that might be having difficulty seeing. All right, so I have to distribute a negative 5 with the 5y. Otherwise, I'm going to get the wrong answer. So I have a negative 5 times 6, which is actually a negative 30. And then my x squared stays the same. My y stays the same as well. Then I have negative 5 times that positive 3, which is a negative 15. And then I have x, and then a y times y, which produces y squared. Last one, I have a negative 5 times a positive 4, which is a negative 20. And then I have y times y squared, which is y cubed. So right now you're looking at probably a whole lot of crazy. So we're still going to follow that same step after we've distributed, which is step 3 that tells us to combine like terms. Keeping in mind that whatever letter combination you have has to be the same for it to be a like term. So right here I have an x cubed. There aren't any other x cubed. When you see that you have xy in all 4 of these terms, the only way that they can be a like term is if it has the same letter with the same exponent and another same letter with the same exponent. So as you can see right here, these x's aren't the same even though they both are x's. These y's aren't the same even though they're both y's, so those can't combine. What I really want to find is another x squared with a y to a power of 1, which would be right here. So this term and this term are alike. And then I have the same thing going on here, where I have an x to the power of 1, a y to the power of 2. So these guys can combine. All right, so let's start combining and see what happens. So we've already established that we have no other x cubed. Again, cross them out so you don't get messed up. Let's go ahead and do this part. So I have 12 minus 30, which would produce, excuse me, not plus, it would become a negative 18 x squared y. So these have been combined. These are like terms. I have 16 minus 15, which is just a positive 1. And then last I have minus 20y cubed. All right, I am gonna check to see if you're, okay, to see how your handout did it. All right, and then if you look, you should see this answer choice on your handout. I wish that I could ask you questions right away, make sure you're good to go. At this point, I'm showing you 2 examples with that third example that was just review. What you would want to do next is look at those 2 options of assignments and pick either the kaleidoscope or the matching assignment. It does not matter. And make sure you show all your work. Both of them are self-checking. So even if it's a little off, go back and check your work and see if maybe you just forgot to add exponents or you combined like terms incorrectly, and problem solve at that point. Again, you can contact me with any questions that you have, whether it's through the Remind app, email, and then of course live grades. All right, I hope you're doing well, and the next video will be day 7, so keep a lookout. Take care.